So this area that is to be taken into account, that is the area around the tank. So the optimum size of the wall is determined in such a way that the distance A, that is from the retaining wall to the tank wall, that should be 0.27 times the radius of the tank. Now how this, that is 0.27, is obtained, that we will see first. Now the area around the tank first we will consider, right? Area around the tank, that is pi r plus a square minus pi r square. Pi r square, that is the area of a tank, and a plus r, that is the area of a tank plus the area surrounded by that. So this is the actual area around the tank. This is the total area minus the tank area that we are considering. This is the area around the tank. So after simplification, this can be simplified, that is pi r square and this pi r square get cancelled. So remaining is 2 pi r a, pi a square, right? Now I am dividing this by r square and here by r and again multiplied by r. So this will become r square, and here also I am multiplying it with the r square. Divide and multiplied by r square to this and divide and multiplied by r here, so that a upon r, that will be written as k. A upon r, that will be written as k. So a upon r, a square upon r square, that will become equals to k square. So this is 2 pi r square into k and 2 pi k square into this r square. So I have taken out the common as pi r square k into bracket k plus 2. This is the area around the tank. I have got this relation. Now second is the volume. The height h2 to meet the conditions can be calculated. Okay. The volume in the tank above the height h2 and the volume of liquid in the dike area. The volume of the tank above the height h2, that means if this is the h1, so this is what the volume of the tank above the height h2, that is nothing but h1 minus h2, h1 minus h2, this will be the h1 minus h2. So this much amount of the volume is going where? In this outside the tank. यहाँ पे का जो कुछ वॉल्यूम रहेगा that will be same as this volume above H2. So This is the pi r square. H1 minus H2 is nothing but the volume in the tank above height H2, right? H1 minus H2 is the above the height H2. This is pi r square. You are making it a volume. So, and this will be equals to the volume of liquid in the dike area. This is the volume of liquid in the dike area. We have already seen the area of around the tank. That is, this is what the area around the tank. That is pi a plus r square minus pi r square. This is what we have talked about, the area around the tank. So we are making it a volume by multiplying it with the H2. So after simplification, you will cut this r square H2 and this r square H2, and then simplifying this H2, which is equal to r upon a plus r square into H1. Writing this a upon r, which is equal to the k a upon r, which is equal to the k. So this r will get cancelled, this r will get cancelled, and you will be remaining with the k plus 1 square. So you are having this equation as h2 upon h1, which is equal to 1 upon 1 plus k square. And the second equation is with you is this equation pi r square k into k square plus 1. Now this is the area around the tank. Now you are putting a certain area, means you are paying a cost for that. So let the cost factor for the area is m. Now this m is having the units of rupees per meter square. This m is having the units of rupees per meter square, and L is the cost in rupees only. Cost of the area around the tank in rupees, and the cost factor m, that is having the units of rupees per meter square. When you go into the market, you will get a cost itne square foot ka area hai, 1000 rupees per square foot, that is the cost of a land. So when you purchase a plot of 1500 square feet, you have to pay the 15 lakh rupees. So similarly, that is the cost of a land around the tank. That is nothing but L, that is in rupees, and its cost factor rate. Cost factor is nothing but a rate. So this is rupees per meter square. So this is the total cost, and this is the area around the tank what we have calculated here. Area around the tank, pi r square k into bracket k plus 2, pi r square into k plus k plus 2 into the m, that is the rate. So I have simplified it, L upon m pi r square, which is equal to k into bracket k plus 2. Now for any given size of the tank of radius r, the minimum cost of the area will occur when the expression k plus 2, that is the minimum. So this is minimum, this expression that will be the minimum. And for the same tank size, the minimum cost of the retaining wall will occur when h2 upon h1 that is plotted. So h2 upon n1, h2 upon h1, which is equal to L upon m k square. So this will become the simplified equation of L upon m pi r square, which is equal to h2 upon l1 h1. So we have substituted his values, cross multiplied it, then we are adding this on both the sides. K plus 1 square is added on both the sides for simplification purpose. So this become k square plus 2k as it is, plus k plus 1 square minus 1, this 1 that will go on this side. So it will become minus 1. So you will get this k plus 1 whole square, here also k plus 1 whole square. So remaining will be this term, and this is 1 for here, and this is minus 1. This minus 1 that will be as it is. So this term that is nothing but k plus 1 square. So now it's a k plus 1 raised to 4 minus k plus 1 square minus 1, which is equal to 0. So this is similar to your y square minus y minus 1, which is equal to 0. And if you are having the roots for this, you will calculate y, which is equal to b plus minus root of b square minus 4ac upon 2a. From there you can calculate this y, which is nothing but k plus 1 square, which is equal to 1 plus minus root of 5 upon 2. So after further simplification, you will get the value of k as 0.272. So this is the k which comes as the 0.272. K is nothing but A upon R. A is the area around the tank. Area around the tank, and R is the radius. So area around the tank, that should be 0.272 times the radius. So this is what 0.272 that is coming into the picture. Now based on this, we will solve the one problem associated with this. So the engineer that is working in a soybean oil refinery industry of production 1 ton per day. The company has given a space of 17,200 feet square to design the storage tank of capacity of 1 crore liter capacity. The plate size are 3 into 1.5 meter in varying thicknesses that is available in the market. The permissible stresses of material is 1300 kgs per centimeter square. The density of the soybean oil, that is 960 kgs per centimeter square. The joint efficiency is 90%. There is no corrosion allowance. How many plates are required for the size of 3 meter by 1.5 meter, and of which thickness? The material, that is carbon steel, with permissible stresses of 1420 kgs per. Okay, density of the material, that is 770 kgs per centimeter cube. The slope permissible in conical roof is 1 in 5. Superimposed load is 125 kgs per meter square. Modulus of elasticity, that is 2 into 10 to the power 4 kgs per millimeter square. Now the volume, that is 1 crore liter, that is nothing but 1 into 10 to the power 7 liters. which is nothing but 10 to the power 4 meter cube. Now the company has allotted a space of 17,200 feet square area. That is, when you convert it into the meters, it is around 1600 meters square. Roughly one decimal place it is shifted. So it is around 1600 meters square. That means a 40 meter by 40 meter space that is available. 40 meter by 40 meter space is available for this. And for this, we can use the tank diameter of 30. So A upon R, which is equal to 0.272, and for 15 that will be the radius, so A comes out to the 4.08. The diameter of the tank dike is 15 plus 4.08 square into 2. This is on one side. 15 is the radius plus 4.08, that is nothing but the A. So the total diameter from the center of the tank for the dike, that will be 38.16. So look at this figure, that is the 40 meter by 40 meter the tank that is available. The tank is with the 15 meter radius, that is 30 meter diameter, and 4.08 meter is the A value. R is 15 meter. So the total from the center is 19.08. The remaining, that is 0.92, that will be remaining here. So 1.84 minus by 2, which is 0.92, is remaining from the tank diameter. Then what will be the height of the tank? This is based on the restriction that is available for the area. So we are having the area of 1600 meters square. That means the 40 meter by 40 meter space that is available. So by certain experience or by certain trial and error, we have assumed this tank diameter to be the 30 and calculated the value of A as 4.08, the remaining area, so it matches with this 40 meter by 40 meter area. Now what will be the volume? Volume, which is equal to pi by 4 d square into h. Volume is 1 crore liters. That means 10 to the power 4 meter cube. And 30 is the diameter. 30 meter square is nothing but your diameter. So h, that comes as the 14.15 meters. So that is approximated to the 15 meters. So this will be a tank of 30 meter diameter and a height of 15 meters. So similarly, the other calculations, that will be the head at the bottom of the tank, which is nothing but P into rho into h minus 0.3 into 10 where h is in the meters. So rho, that is converted into centimeters, and this is in the meters, and which is converted into the centimeter by multiplying with the 100. So it becomes kgs per centimeter square. So thickness of the tank bottom, that will be PD upon 2fj. So this pressure into the PD diameter, this is written in millimeters, converted into the millimeters, upon this is 2 into 1300. So 1300, that is taken as the F value. This value is 1300, which is given here. So the thickness that comes out as the 18.09 millimeter. So standard plate thickness of 20 millimeter that is used. Now how many number of plates that will be required? Circumference, which is pi d, pi into 30 meter diameter, which is coming as 31.4 meter, 31.4. So approximately 32 plates that is required in the one course. So now assuming the other thickness, assuming the thickness of 18 millimeter, that comes as the 14.925 meters height. Then assuming the thickness of 16 meter, height comes out as the 13.3 meters. So similarly, other heights 14 millimeter, the height comes as 11.95. For 12 millimeter, height is 10.05 meters. For 10 millimeter, height comes as the 8.42. For 8 millimeter, height comes as the 6.8 meters. For 6 millimeter, height comes out as the 5.175 meters. So minimum 6 millimeter thickness plate is used for tank diameters greater than 15 meters. So at the bottom you are having the 20 millimeter thickness plate. Subsequently the thickness plate reduces 18 millimeter, 16, 14, 12, 10, 8 and 6. The upper three layers, that is of a 6 millimeter thickness. So this is what the actual engineer should bring, the 32 plates for each thickness, and for 6 millimeter you require 32 into 3, that is nothing but the 96. Then for suitability of a conical roof, assuming the plate thickness of 6 millimeter for roof plate, then the weight of roof plate, which is nothing but the area of a plate into the thickness into the density. Now the weight per unit area. So this area, that is area of a plate, is taken on this side. So weight of the roof plate upon area of the plate will give you the weight per unit area. So thickness, that is 6 millimeter roof we are assuming. Density of a material is 7700. So this load that is coming as 46.2 kgs per meter square. So total pressure on the roof, which is the superimposed load, that is the person which is standing on the roof, plus the weight of the roof itself, roof plate. So that will be the total pressure on the roof. So this is 125 plus 46.2, that is kgs per meter square. Then sine theta, which is nothing but d upon t root of p upon 0.2404 e. So sine theta, that is coming as 1.02. Then tan theta, that becomes undefined. So this cannot be used. Then assuming the plate thickness of 20 millimeter, again the slope that comes as the 1 in 3.09. So you require a slope of 1 in 5. So it is greater than the permissible slope. It will therefore not desirable to use a self-supported roof as the tank diameter is 30 meters. So the tank diameters are more than 15 meters, then this self-supported roof doesn't give the proper value of this slope. Only for the tanks below 10 meter, 15 meter, you can get the self-supported roof.